Okay, so now I'm going to demonstrate and draw a couple planes using points and vectors on the 3D grid here, 3D Cartesian plane. So notice here that I can rotate this around by just clicking and dragging to kind of get the feel for what a three-dimensional space kind of looks like. It's hard to draw on a chalkboard or on paper, but this is basically what the 3D space is all about. So in the examples that we saw, the first example, I'm going to go up here and draw a vector equation, and let me see, the position vector of the specific point was 0, 1, 2, so I'm going to click on this second 0 and click here to get 1 there. I'm going to click twice here to go up to 2. And for the first parameter, that was at -4, 0, and 3. And I'll get that. And then for the next vector, I'm going to click on here, which is -3, 0, 0. Okay, so the plane has been formed. And if we click and sort of move this around, we can kind of get a feel for how the plane is positioned. We see that because we're looking down the edge of the plane right here, the plane is actually parallel to the XZ plane. As we rotate this around, we see that it's parallel to the XZ. And that's shown by the zeros in the Y positions of the direction vectors. So we have two non-collinear direction vectors which form the basis for this plane, and that plane is going through this point 0, 1, 2. Now I could change that point, and we could then see how the plane would correspond to that. So suppose I change the Y value of this. We see that as the Y value gets bigger, the plane moves further and further away from the origin, away from the XZ plane, okay, corresponding to that Y value of the point that it has to go through. So it's going through the point 0, 13, 2. Okay, so that demonstrates from our first example the plane whose direction vectors are based on -4, 0, 3 and -3, 0, 0. Okay, so I'm going to now clear this, and I'm going to form another direction vector, and this one is from the next example where we were trying to see if the 3 points given would actually determine the plane. And so for the point, I'm going to use the first point A, 2, 3, and -1. And the first direction vector was 6, 2, and -4. And the third was -3. So see, we've got a plane here. I haven't finished with that second direction vector though, but in the meantime it's kind of formed a plane that would be formed given these two direction vectors. And then I'll add in here -1, so of course the plane changes again. So it's going through the X and Y axes, and it's parallel to the Z axis. You can see it's parallel to the Z axis there. And now let's just see what happens when I change this last component of the direction vector to 2. See, now the plane has disappeared because these two direction vectors are collinear. They're scalar multiples of each other, which means they're both parallel, which means that you cannot form a plane from two collinear vectors, because it would just be like a piece of paper spinning around on a string or around a pencil or something. There's not the basis to actually form a plane and keep it stable. Okay, so that just gives you a little demonstration, and if I were to increase this even one more, there's our plane is back again. Okay, so it shows how temperamental planes and direction vectors are. So that just shows you that you need two non-collinear vectors to form a plane.